This is the third part of your immune system notes, and we're going to start on the back side of the big sheet down where this graph is. And we're going to start to talk about the numbers and see how the amount of antibodies changes over time when you get an infection. So let's go ahead and, let's zoom in and look at this graph. So on the y-axis, we have the antibody concentration in the bloodstream, On the on the y-axis, on the x-axis, we have time in days. So essentially, let's just talk about chickenpox for this example. Chickenpox is something I had. You probably have a vaccine for it, which we'll talk about in a second. But when you initially get an infection like chickenpox, remember that your primary immune system, that's not the primary immune system. This is the primary immune system. Where is it? There it is. There it is. All right, this first line of defense that we talked about all the way back in that first video, the external barriers, your skin, etc. Obviously, again, you have openings. So if you know chickenpox virus, I probably breathed it in with my respiratory system. But a lot of this stuff is not in high concentration. You know, you have a lot of phagocytic cells and white blood cells, etc. But it's not. I was gonna say it's easy to get by, but it's not the hardest thing to do either. So by this point, when you say you have an infection, it means that your primary immune system has been breached, and it is up to your humoral and cellular responses, right? So as the virus particles enter the body and they start infecting cells, they pretty much go undetected for the most part for the first 2 days, so the concentration of antibodies stays low. But eventually, by chance, because remember these things are just kind of moving around in the bloodstream, the virus or the bacteria will bump into a B cell, and the antibody and the antigen will match, one of the millions of B cells in your body. And that's when the antibody response really ramps up, because that is when your B cells will start dividing and make plasma B cells that make antibodies, right? So that takes about 2 days, and the level of antibodies in your blood will peak at roughly 7 to 14 days. So 1 to 2 weeks is how long it takes for the maximum amount of antibodies to be in your bloodstream. And if this is the first time you ever saw that virus, then this is called your primary response. That just means primary. So primary response, right? You've mass produced a lot of antibodies, right? You've activated maybe your white blood cells. Remember we talked about these from before? Where did they go? Here they are. Your macrophages from before have engulfed, the virus, if we're doing the chickenpox virus, and they've become APCs, right? And some of them have activated these T helper cells, these cytotoxic T cells, because remember, those are cells that get activated directly by the APCs, right? Whereas the virus itself with its antigen would activate like a B cell, right? So that takes time. It takes about 1 to 2 weeks, and that's when the antibody production is highest, right? So after that, your immune system starts to win out. Virus particles are, destroyed, and the amount of antibodies that your body needs just decreases. But you don't lose all of the antibodies. You keep some of them, and that happens at about 3 weeks. Right, so in about 3 weeks, you're done feeling bad. You kind of have recovered from, I don't know, the flu or the cold or whatever, or the chicken pox. You've gone over the itchiness phase. If you've never had chicken pox, they are very, very itchy. It's like a whole bunch of bug bites everywhere. But your body does retain leftover antibodies, and they stay with you until you die, All right, so these are leftover antibodies that are ready to recognize any, second infection that you get. And remember, it's not just the antibodies that you're left over with that can respond to a second infection. Remember, all of these cells, the B cells, you have memory versions of them. So you have memory B cells, right? I'm going to zoom out here just so you can see it a little bit better. But you have memory T helper cells. You have memory cytotoxic cells once you've had, an infection. So you have an entire armada of cells and antibodies ready to react to a second infection. So you can imagine that a second infection, you might not even notice it because your immune system reacts so quick, right? But let's say that maybe I did get chickenpox again. I got chickenpox for a second time. Well, what's going to happen is some of that chickenpox virus will activate my memory B cells directly. Right. So here is my chickenpox virus on its second trip into my body. And my memory B cells are like, oh, I recognize you from before. And they're going to divide, right? They're going to divide into more memory cells. Oops, not member cells, memory B cells. And they're going to divide into more plasma B cells, right? And this is what we mean when we say that the immune system is ready to react again. Those memory cells are already present and they're ready to divide if they ever see that virus again, right? And then you just go on doing what you did before. You make more antibodies, you make more memory cells, etc., right? Same thing is true for your T helper cells that are gonna, your memory T helper cells will divide and make, again, more memory cells, but they'll also make more T helper cells, right? Those T helper cells make cytokines that stimulate cell division, right? Same thing with the memory cytotoxic cells. They will make more memory cytotoxic cells, MEMC for cytotoxic, but they will also make more cytotoxic T cells that act like natural killer cells, right? So these are all the cells that are already in your body, ready to go again if that virus, antigen, whatever, bacteria shows up a second or a third or fourth time around, right? So let's graph this. So here's my second chickenpox infection. Let's say like a year and a half later, I get it again. I get a massive spike of antibodies much quicker in about 2 to 7 days. I might not even realize that I'm sick. I might feel a little bit fatigued or tired, but that's probably about it. And when my immune system has, that's not lines all crooked like that. When that immune system has fought off that infection again, probably before I've even realized I've been infected, I'm going to have more leftover antibodies. So by the second infection, I have, even more antibodies left over than before, right? This is called the secondary response. All right. So that's kind of how you would relate the number of antibodies over time, based on whether you've had the infection before with a secondary response, or maybe it's your first time. So what's the association with vaccines? Because this is a great time to talk about vaccines. Vaccines basically pretend to be the primary response. And what the vaccine itself is one of two things. It's either an inactivated pathogen, so it might be an inactivated virus. Let's talk about COVID. It might be an inactivated COVID virus, or it might be a part of the pathogen, a part of the virus that contains the antigen and gets injected into the bloodstream. But the point is that neither the inactive viral or bacteria or whatever it is or the protein or the antigen that's attached to it is going to make you sick, right? Sometimes people have a little bit of a response to a vaccine just because their immune system is learning and they might have some symptoms of it. But vaccines do not give you the illness that they are vaccinating you against. So with that said, let's go ahead and where do I want to go next? Give me a second here to think. Let's go to HIV. All right, so let's back up to COVID. So COVID, there are two vaccines for COVID. One of them, or two tests for COVID, I'm sorry. One of them involves the nose swab. In that case, they're testing for the actual virus itself. Or you could test for antibodies, right? So let's say that, I got COVID, or let's say, I got chickenpox. Well, what are they testing for? They could actively test for the virus, but they're probably going to test for antibodies. And, why might I have antibodies? Why might I have antibodies for COVID in my bloodstream? Well, it could be that I've had the vaccine for it, right? And my body responded appropriately and produced antibodies in case it actually saw COVID. Or it could mean that I actually had COVID itself and my body's produced antibodies to respond to it, right? And that's what these two, the Pfizer and I think Moderna, are producing. That's their vaccine that they're getting run through the FDA at the moment, right? But let's look at something different like HIV, because HIV has not been successful with a vaccine and getting the body to produce reliable antibodies to the virus. And this is the reason why. HIV infects macrophages and dendritic cells. Remember that macrophages and dendritic cells are antigen-presenting cells, right? So these cells are basically out of commission. Well, if you go back up here, you'll notice that your entire cellular response, all of your T cell response, the helper T and the cytotoxic T cells, are activated by antigen-presenting cells. So that means the entirety of your cellular response is out of commission when you have HIV. Not only that, but because your helper T cells can no longer make cytokines because they're all dead, your B cells do not get the cheerleading, they do not get the stimulation they need from the cytokines to differentiate into the plasma B cells that produce the antibodies, which means your antibody count is going to remain very, very low. And this is why HIV is so hard to kill, not only because it has a lot of different, the mutation rate's fairly high, but also because it actually kills the actual cells that are responsible for triggering the immune system, right? And a lot of our vaccines rely on an immune system response. It's hard to do that when your immune system can't respond. So that's why this is such a dangerous and quite frankly scary virus. The other thing is that HIV will infect T helper cells themselves, and they can't produce cytokines that way either. So I'll go ahead and write that. No cytokine production. So I believe that's what I want to talk about here. Let me know if you have any questions in class. I'm just double checking really quick. This is a pretty short video. Primary versus secondary response, vaccines, how they work, what they are. Yep, I think that looks good. So we'll talk about this in class, and I will see you next time.